Okay, so let's talk about Heron or Heron's formula, however you want to pronounce it. I say Heron, so we say Heron's formula now. So let's say you have a triangle, right? And we all know how to find the area of a triangle. So we know the area of a triangle is equal to A is equal to a half AB sine C, right? Let's say if this is length A, this is length B, this is length C, then this would be the angle C, capital C, this would be the angle capital A, and this would be the angle capital B. And you can switch A, B around, you can switch C out, you know how to find the area for a triangle. But, not always we'll be given two lengths and an angle. Sometimes we may just be given the length of a triangle. So let's say we had a triangle that looked like this. Let's say that's what a triangle looked like, right? And let's say we were given the length. So let's say we were given 6, 8, and here we were given 4.79. Let's say those are the lengths we're given. So how would you calculate the area of this triangle? Well, there are two ways to do it. So the first way that we all know is use the cosine rule, right? So the cosine rule, which says a squared is equal to b squared plus c squared minus 2bc cos a. We all know how to do this. Then you find the length, you find the cosine of this angle here. You take the cos inverse, and then you will get that angle, and then you can use that in the formula and get the answer. But I'll tell you a better way to do it. So there's something called Heron's formula, and what it is that it says the area A is equal to, this is not the angle A anymore, this is the area. So let's write AR. So the area is equal to, this is also AR, the square root of, and I'm gonna write some things first, and then I'll explain to you what they mean. So you have S times S minus A times S minus B times S minus C. And all S is just the semi-perimeter. So it's just A plus B plus C divided by 2. So it's all the lengths of the triangle and then divided by 2. You add up all the lengths and divide by 2. So in our case, let's find it using the Heron's formula, and then we'll confirm using the cosine rule and the formula for the area of a triangle that we know, and see if they're close enough. Because we're going to be rounding, so we won't get the exact same answer. So the area should be equal to, well, if you do A plus B plus C divided by 2, we get 8 plus 6 plus 4.79 divided by 2, which is 9. Let's make it 9.40. So we have S is equal to 9.40. Then the area is the square root of, well, 9.4 times 9.4 minus 8 is 1.4. 9.4 minus 6 is, of course, 3.4. And then let's see, 9.4 minus 4.79. So 9.4 minus 4.79 is 4.61. So let's do 4.6, one decimal place. And I'm going to put this all in my calculator and get the answer. So 4.6 times 3.4 times 1.4 times 9.4. And then square root it gives me 14.36. So the area is approximately 14.36. I say approximately because we obviously rounded a lot. Now let's use the cosine rule and see if you get the same answer. So according to our calculations, if you're trying to find this A right here, then that is going to be, so let's do it using the cosine rule. So we have, so if you rearrange, we'll get A squared minus B squared minus C squared divided by negative 2BC is equal to cos A. I'm just going to put in the numbers in my calculator. So we have 8 squared, so we have 64 minus 36 minus 4.79 squared divided by negative 2 times 6 times 4.79. So I'm getting negative 0.088 as cos A. I find the cos inverse of that, I get 95 degrees. So I get A is equal to 95.05 degrees. And now we know how to find the area of the triangle. We just do half AB sine C. So we do a half times 6 times 4.79 times sine of 95.05. And I get 14.31. So I get area is equal to 14.31. And is that what we got with the other formula? Well, almost. We got 14.36 here and we got 14.31 here. And of course we rounded in both places, but the area is the same, and you can believe me on that. And that's because this formula right here, this Heron's formula, and the cosine rule are actually related, because the cosine rule comes from the Heron's formula, and Heron's formula also leads to the cosine rule. So of course you get the same answer. And we won't go into the proof of this formula because it gets kind of complicated with the algebra, but it works. And this is way more reliable because in an ideal scenario, like in a real life scenario, in fact, not ideal, you won't be given the angles of a triangle. Like whenever you see a triangle, you're not thinking about the angle between two sides, because usually you just think about the side length, right? So we're literally gonna make something up. So let's make it 3, let's make this 5, and let's make this 6. Let's say I want to find the area of this triangle. This is a way more realistic situation than me giving you 3, 5, and then I give you that angle there, because we really can't tell the angle just by using our eyes, but we can tell the length usually. We can just measure it out pretty simply, right? So let's find the area. So first find the semi-perimeter, which is 3 plus 5 plus 6 divided by 2, which is 7. So then area is equal to square root of 7 times 7 minus 3 is 4. 7 minus 6 is 1. 7 minus 5 is 2. So this is the square root of 56. And I will say that's approximately 7.5. Let's just say 7.5. I don't know what the answer is, but I'm going to say 7.5. And now I'm going to go and do it in my notebook, and then I'll put the actual answer up on the side, and let's see how close we were. Okay, so I should have put the calculation up, and we got 7.48 as our answer. And look at what we did. But I literally made these numbers up on the spot, I promised you. So over here, 4.79, I chose it before on purpose because that's an example I used to make the question up. That's what I was like planning to make for the video. But this right here, I made it up on the spot, and we got 7.5 as our answer. And the actual answer is around 7.48. But look, this is a way more realistic situation. It's much more difficult to calculate the angle between two sides than to actually calculate the length of the sides, right? And in a realistic scenario, that's what you'll be given. You will just have 3 lengths, and you're told to find the area. And now, using this formula, look at how close we got to the area. We got 7.5, and the answer was 7.48. And we didn't need no angles, we didn't need any trig, we just needed literally simple addition, subtraction, multiplication, and taking the square root. And if we actually took the square root of 56, let me do it right now on my calculator, it's 7.48, which would be the right answer. So we were very close with our approximation of 7.5. So you can see how useful this formula is. This is a very realistic formula compared to what we get with the cosine rule and this general area formula. Of course, these are very useful, and these are also correct because they come from this and this comes from them. But in a realistic scenario, you really won't have the angle given to you. You'll mainly just have the sides given to you. And if you want to calculate the area of a triangle from this side, well, now you know how to do it. You don't need the angle anymore. So yeah, that's Heron's formula. You can search up more about it. But yeah, like, comment, subscribe, and I hope you enjoy, like a special type of video, because you don't really see this usually in class.